Today you will be learning about mechanics of materials. Mechanical properties describe how a material reacts when a force is applied to it, and how much force a material can withstand without breaking. This is called toughness. In other words, mechanical properties describe how strong a material is. Let's start with some basic terms and definitions. When you deal with mechanical properties, you talk a lot about forces and loads. A load refers to the overall weight of any given force acting on a material. For example, cars driving over a bridge, or myself standing in this room. A force is simply a push or a pull. There are 5 main categories of forces: compression, tension, bending, torsion, and shear. Compression is squeezing forces. Compression strength refers to how much a material can be squeezed before breaking. Tension deals with tensile strength, or how much a material can be pulled apart without breaking. Bending refers to how much a material can be bent without failing. In other words, how ductile or pliable a material is. Torsion deals with twisting forces. Shear refers to sliding forces, when one part of the material is pushed in one direction and another part of the material is pushed in the opposite direction. Many types of materials are strong in one of these categories, but weak in others. For instance, chalk has high compression strength, but low tensile and bending strength. The same can be said for glass. Also, a rubber band has high bending strength, but low tensile strength. All of these mechanical properties relate to stress and strain, which are the 2 major concepts you talk about when you discuss mechanics of materials. So, what are stress and strain? Well, let me explain. A load or weight applied to a material will create forces, which we just talked about. These internal forces in the material are called stress. The stresses acting on the material will cause the object to change shape or deform. The amount or measurement of this deformation is called strain. To sum it all up, stress refers to the forces acting on the material, and strain deals with how the material deforms and otherwise reacts to those forces. The relationship between stress and strain and overall material strength is represented graphically through a stress-strain curve. In a stress-strain curve, the amount of deformation of a material, or strain, is recorded in relation to the amount of loading, or stress, the material is experiencing. Strain is plotted along the x-axis, and stress is plotted along the y-axis. So you might be asking, how do you interpret a stress-strain curve? Well, let me explain. For a certain period of time, a material will be able to undergo stress without permanently changing shape. This area of the stress-strain curve is known as the elastic region. After a certain point, called the yield point, the material will no longer be able to withstand additional stress without permanently changing its shape. After this point is passed, the material enters an area of the stress-strain curve that's called the plastic region, where you will see permanent material deformation. Eventually, if enough stress is applied, the material will break or fail. This point on the stress-strain curve is called the failure point. Naturally, every material's stress-strain curve is unique and will look a bit different than the one you see here. Since stress-strain curves reflect the specific mechanical properties of any given material, they are frequently used by engineers to predict material strength. This is really important in product and structure design, when engineers must select materials that meet specific strength criteria.